Hi, my name is Max. This is the solution to the Xorbitant challenge. The Xorbitant challenge is a cryptography challenge based on XOR encryption. The prompt is that the user has created an encrypted message. However, instead of encrypting it with a one-time pad, as they should do, they have used a short key and repeated it several times. We can use this fact to break the encryption and obtain the flag to the challenge. To start out, I'm going to open Python and copy the ciphertext into Python. You can see that we have the ciphertext. The next step is realizing that the flag format given to us can reveal some bytes of the key. We know that the flag starts with SC5 and then an opening squiggly bracket. So if we take the first few bytes of the ciphertext and XOR them with these first bytes, we can obtain the first bytes of the key. Let's go ahead and do that. In this code, you can see that I am creating a new set of bytes by computing A XOR B, where A is the ciphertext and B is the literal string SC5. Having run this, we can see that we have obtained 4 values. This, however, is only part of the key and is not sufficient to solve the challenge. If we attempt to repeat this partial key over and over again and decrypt the ciphertext, we'll get some garbage out. You can see that the first few letters repeat properly, but the rest of this is gibberish. After playing around, one thing that might occur to the student is to try and identify the actual length of the key. They can do this through a relatively brute force process of attempting to decrypt the message using various length keys until they find one that looks mostly correct. I'll demonstrate that here. First, I'll create a function that allows me to write a shorthand for this decryption routine because it's a little bit long and annoying to write. Then I will call this function and print the output, trying various length keys by appending the letter A to the key part that I already know. Note, it doesn't particularly matter what byte you append so long as you add some symbol or character. You'll notice that the key of length 6, which was created by appending 2 A's to the original key part, looks vaguely like English. There are some sections that seem like they might be correct. This is the first step in identifying what the full key is. For the next part, we have to understand what those next characters are. There's a few ways of doing this. One approach is to brute force every possible value for those 2 extra bytes of the key. However, I'm going to use a different approach. What I'm going to do is look at this partially decrypted string and identify certain sections that look like they might be relevant. I see FRAG something something E. To me, that looks like that might be the word fragile. So what I'm going to do is make a guess that this character, the dash, is supposed to be an I, and figure out what key would correspond to that. To do this, I'm first going to figure out what byte of the ciphertext that is, and then I'm going to compute the ciphertext XOR the letter I to figure out that byte of the key. If I just count this by hand, I'll see that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Of course, in this case, we were starting at index 0, so that should be 22. If I then compute ciphertext at index 22, XOR the byte I, oops, I'll get the value 37. Converting that back to a character gives me a percent sign. So now which byte of the key does this correspond to? Well, we know that the key is repeated over and over again, and we know that the key is length 6. And we were looking at the character at index 22. So if we take 22 mod 6, this will tell us that we've just found the value of byte 4 of the key. We already know bytes 0 through 3, so we can update our key part to be the new value that we know. You can now see that this is of length 5. By attempting to decrypt again with this new value for the key part, we can figure out more of the solution and see if our guess was correct. Notice that this time I'm only adding one A because we know that the overall key is of length 6 and the part that we know is length 5. We can see that this does in fact look to be closer to the solution. This seems to be almost correct English. Again, I'll go and identify that this looks like this should be fragile. However, you might be able to make a few other guesses. You could guess that this is XOR. You could guess really. You could guess that this is actually supposed to be an underscore, as you can start to see that underscores are used to separate words. Repeating the same process, we know that this character was index 22, so this character will be index 23. And again, the word guess is fragile, so we're going to look at the representation of the character L. This gives us the 0 character. So the key that we have obtained can be figured out by taking the key part from earlier and appending the byte 0 to it. Now, if we attempt to decrypt one more time, we should see the full flag as a result. And there you go. SC5, XOR is really fragile if misused.